Hello, fellow cloud enthusiasts. My name is warnerbell, and today we're going to be building a Teams communication solution using Mattermost and AWS. Mattermost is a self-hosted open source chat platform that is designed for team collaboration. It is similar to other chat platforms like Slack and Microsoft Teams, but it can be run on your own servers, giving you more control over your data and infrastructure. Mattermost offers many of the same features as other chat platforms, including support for real-time messaging, file sharing, and integrations. It's widely used by organizations as a platform for communication and collaboration among team members. This project will help you sharpen your skills by incorporating multiple AWS services using the AWS console and the CLI. We will build the solution from scratch using our necessary services from end to complete a viable solution. Some of the services we'll be using include AWS VPC, EC2, security groups, Internet Gateway, NAT Gateway, and more. A scenario where this project might be useful to a cloud engineer is that their organization might have compliance policies in place which do not allow them to use services managed by third parties. In that situation, they would prefer a solution that can be managed and hosted on their own servers and controlled by them. In a scenario like that, a project like this might be a viable solution. Here is an example of what the architecture will look like upon completion of the project. And with that, we'll go ahead and get started with the project. All right, here we are at our AWS console. And the first service that we are going to use and configure is going to be a VPC. So we'll go ahead and start setting that up. We're hit our VPC dashboard. We're going to say create a VPC. This will be VPC only. We're going to name this comms VPC. We're going to set the CIDR to be 10.0.0.0.0. It's going to be /16. Everything else can stay at the defaults, and we're going to click create. We're going to go back to your VPCs. As you can see, we have our VPC here. It says available. Click the checkbox next to the VPC, go to actions. We're going to edit VPC settings. We're going to click enable DNS hostname. DNS hostnames is an attribute that determines whether the instances launched in the VPC receive public DNS hostnames that correspond to their public IP addresses. That's what we want, and that's why we're choosing it. Click save. Now we have our VPC created. The next thing we want to do is go ahead and create some subnets. So we'll go over here to the left and we'll click subnets. Now we're going to create a public and a private subnet. We're going to place our application server in the public subnet. We're going to use it as a jump host or a bastion host in order to log into our database instance that will be in a private subnet on another server. So click subnets, click create subnet, select the VPC the subnet is going in. That's going to be comms VPC, the new one we just created. This subnet's name is going to be comms public. Availability zone is going to be US East North Virginia. CIDR block is going to be 10.0.1.0, and this is going to be a /24. Nothing else needs to be done unless you want to add tags. We're going to click create. As you can see, we got our comms public subnet and the CIDR of it. We're going to create a private subnet. We're going to select the comms VPC. We're going to say comms private. Availability zone is going to be US East 1. This will be 10.0.2.0 /24. Everything else stays the same. Create subnet. And as you can see, we got comms private, comms public. All right, so on our public subnet, let's click the box next to it. Let's go to actions. Let's go to edit subnet settings. And we want to enable auto assign public IP for addresses. And we're going to click save. That's so we can get a public IP on this public subnet. All right. The next thing we're going to do is create a internet gateway so that our public subnet can communicate over the internet. So on the left-hand side here, we're going to go down in the left-hand bar, internet gateway. We're going to create an internet gateway. We're going to call this comms IGW for internet gateway. All we need is a name tag. If you want to add more, you can. Otherwise, click create gateway. What we're going to do is go over here to actions. We're going to attach the VPC and we're going to attach it to our comms VPC and attach internet gateway. Now our internet gateway is attached. The next step in our project is to create some route tables. So we're going to go over here to route tables. We're going to create public and private route tables. We'll click on create a route table. This is going to be -RT. It's going to go in the comms VPC. Name tags enough. We're going to create and create another one. All right. Create a route table. This is going to be -RT. It's going to go on comms VPC. And we're going to create that route table. If we look at our route tables, you see we got comms pub and comms priv. Okay, so now that we have our route tables, the next thing we need to do is create a route to our internet gateway. So we're going to click on the route table ID. We're going to go down to edit routes. We're going to add a route. It's going to be from anywhere, all zeros. And our target is going to be our internet gateway we just created, comms IGW. And we're going to save those changes. We're also going to associate this route table with our public subnet. So we'll go here to subnet associations, edit subnet associations, and we want to click comms public and save that association. So now that our public route table has a route to our internet gateway and it is associated with our public subnet. Okay, the next step is to do the same for the private route table. We need to associate it with our private subnet, and we also need to give it a route to a NAT gateway, which we have not created yet. So let's go ahead and do that now. We're going to go over here to NAT gateways, and we will create a NAT gateway. And we're going to call this NGW. All right, and we're going to put this in the public subway. NAT gateway goes in public. So comms public. We need to allocate an elastic IP for this gateway, and there it is. And we're going to create the gateway. Now that our gateway is created, we're going to go back to our route table, and we want to set up our private route table. So we're going to click on the route table ID. We are going to edit the routes. We're going to add a route from anywhere to our NAT gateway, and we're going to save changes. Now, obviously, these routes are from anywhere so that we can communicate and set this up. In a production environment, you might pare down those routes to a specific set of IP addresses. We're going to keep on moving. We need to associate this route table with our private. Or did we do that already? Yeah. We'll just make sure we did and save. All right, so we've got our route to our NAT gateway, and we've got an explicit association to our private subnet. The next thing we're going to do is we're going to create our application server. So we will go to EC2. I have a EC2 up in a tab already. Then we're going to go ahead and launch instance so we can create our application server instance. We're going to name this comms app server. We're going to use a Linux OS for this. We're going to stay free tier eligible Amazon Linux 2, and we're going to stay T2 micro. We're going to create a key pair. Our key pair name is going to be comms new key pair. Create.pem file, and we've saved it to our local computer. Network settings, we're going to go here and edit. We're going to do our comms VPC, and this is the app server, so it's going in the public comms public subnet. Auto assign public IP is enabled. Let's go ahead and create a new security group. No, we're going to create a new security group. We're going to call it comms-sg, comms security group, communications security group. Now, we definitely want to have SSH on port 22 so we can log into the server, but we're going to add a couple of more security rules, okay? So we're going to also add HTTP. Did I say 3 T's? HTTP? I don't know. On port 80, we're going to also add HTTPS for port 443. We're going to also add a MySQL/Aurora type, and that is port 3306 TCP. We're going to go ahead and launch instance. What? I didn't add my CIDR prefixes. Okay. We're moving a little too fast here. Okay, so we're going to say the source is from anywhere. The source is from anywhere. The source is from anywhere. Again, if this was production, you might want to have the source be a specific IP address or a range of IP addresses. We're going to launch this instance, and it should pop up in running instances in just a moment. Okay, now we see that our instance is running. We click on the box, we'll see the information about it. Click on the security tab. Let's go to the security group for our EC2 instance. And under inbound rules, we're going to edit these rules, and we need to add one more rule, and that is for custom TPC. And we're going to do port 8065. And the source is from anywhere, and we're going to save. All right. All right. Let's go back to the dashboard. We've got our comms app server ready. Now we need to launch our database server. So let's go ahead and launch instances. This is going to be the comms/db server. We're again going to use Amazon Linux AMI, and we're going to use T2 micro for the instance type. We're going to use the key pair we created, comms new key pair, and we're going to check our network settings so that we know that we're on the comms VPC, and we're going to be in the comms private subnet for our database. As you can see, auto assign IP is disabled. The security group we're going to use You could create another one. We could, but we're going to go ahead and use the same one. So we'll select an existing and we'll say comms security group. All right. And everything else should stay the same. Click launch instance. Go back to our dashboard and we'll take a look at our instances as they're spinning up here. As you can see, we built our infrastructure now. We got our app server, our database server. We set up our VPC. We set up our subnets. We set up our routing tables. Everything's ready to go. The comm server is still initializing here, but that should be up soon. Now we can begin installing and configuring our database. Okay, both of our servers are running. Now we need to log into our app server. And what we should probably do first is to copy our .pim file onto the application server so that we can jump from the application server to the database server when we need to. And we should do that before we log in to our app server. Now, there are several different ways to do this. We're going to be using SCP. You could log on to the server, use Nano, copy the text of your key pair, paste it in Nano, so on. There's other ways to do it. We're going to use SCP. We're working on this project from a Windows system, right? So we're going to use PowerShell and SCP to take our .pim file and upload it to our app server. So let's go ahead and open up a notepad. And we're going to use this to edit commands and be able to paste them where we need to. So we're going to put this over here. And let's go ahead and open up PowerShell. A little bit smaller here. Okay. Here is the command we are going to use. And you can find these commands in AWS documentation. You can Google them. They're everywhere. You just need the syntax and then you fill in your information. So we got scp-i, our application server PIM file, which is called, do we know what it's called? If we don't remember what we named our PIM file for the application server, there's several ways we can find that out. Since we're here, we'll just go ahead and click on comms app server. We'll go to connect and the PIM file name is comms new key pair.pim right there. Okay, so then we'll bring back up our notepad. We're gonna paste it right here. Comms new key pair.pim. So SCP is going to find our key pair on our system. Then we're going to paste the same name because this is what we're going to name it on our EC2 instance. Now we need the application server's public IP. So that's going to be right here. If we wanted to see it on the server, public IP, we could copy it here, bring back up our notepad, application servers public IP. We're just going to paste it right in here. And so we have scp-i comms new key pair, comms new key pair.pim. And we want to send it to our EC2 instance, EC2 user at 42.211.254.200 home and the EC2 user directory. Okay, now that we have all of that, let's go over here to PowerShell and we want to navigate to the directory that our key pair is in. So we're going to change directory and we downloaded that straight to downloads. So boom, now we're in the downloads folder. We're going to take our command, make sure we got it all, copy here, and we're going to paste it. We're going to say yes. And it permanently added our server to trusted devices, and comms new key pair is 100% sent over to our server. So now we can go ahead and log into our server, and we'll check and make sure that key pair got transferred. So then we're going to come back up here. We're going to select our EC2 instance that we want to connect to. That's going to be comms app. We're going to say connect. And using this command, we're going to log into our EC2 instance. So we're going to bring up PowerShell. We're going to paste the command in. We're going to say, yes, it's authorized and authenticate. And as you can see, Amazon Linux 2, we are in. If I said, who am I? We are the EC2 user. If I put LS, we can see that our comms new key pair is there. Now, if when you use this command, you get a message that says something like the key pair is public or open to public, you would need to change the permissions on the key pair. AWS kind of gives us the command to use chmod 400 new key pair.pim. It changes the permissions. That's only going to happen on a Linux or a Mac box. There's a couple of different additional steps in order to do that for a Windows system. Also, we logged in to our EC2 instance using PowerShell, but you can log in to the EC2 instance using PuTTY on a Windows system, and there's another process for going about that. But for simplicity's sake, here we are. Okay, so now we are logged into our app server, and we see that we have our key pair on there to use. So now we're going to jump from the app server to the database server. So let's pull up our notepad here. And we are going to use this command to log into the database server. And all we need is database server PIM file, just the name of it. So it's going to be comms new key pair.pem EC2 user at, and we need the private IP address of our database server, and we can get that by going back up here, going to instances. We're going to click on our database server name, and we're going to go right here, private IPv4 address. We're going to copy that. We're going to bring our notepad back up, and we're going to paste that IPv4 address right here. Paste. All right, then we're going to take this whole command, and we're going to jump from our application server into our database server. Okay, we're going to say yes. It says warning, private key file is unprotected. So what did I tell you you're going to have to do? You're going to have to chmod 400 and then comms new key pair.pim. Enter. That changed the permission on the file, and then now let's go log into that server. Boom. And as you can see, 10.0.2.246, 10.0.246, we are now logged into our database server. So what's the first thing you got to do when you log into a new Linux server? You got to run some updates, right? So let's say sudo yum update. Okay, now that we've made sure that our database server is updated or up to date, There are several commands that we're going to use to install and configure our SQL database. And I'm going to paste them right here in my notepad. Copy, paste. And these commands can be gotten from documentation, obviously. First command we are going to take is this one. Paste it in here. And that's going to get us started with downloading our database. Second command. All right, that's complete. We're going to do the third command. And I intend on attaching a document to this video that will have the step-by-step walkthrough in writing so that these commands will be available to you. All right, that one's complete. That one. Copy. Let's see if we can start the service. Okay, now we need to retrieve a temporary password from MySQL. So we're going to use a command here, this command. In order to do that, let's go ahead and go over here, paste it. Boom, as you can see, this is our temporary password. I'm gonna go ahead and copy that and put it on my notepad. Control, there we go. Now we're going to log into our SQL instance using this command. And when prompted, we're gonna put in our password. So let's do that. Okay, it's asking for a password. Let's see if it's gonna let us copy and paste it. This thing is always so tricky because you can't tell if you've actually pasted the command in there. Okay, so as you can see here, we have a MySQL prompt. So I do believe we are in the database. Next, we're going to paste in this command, alter user root at localhost identified by password 42. Query OK, 0 rows affected, 0 seconds. The MySQL pump is there. All right, now we're going to exit out of MySQL. So let's just type in exit. And as you can see, it told us bye and sent us back to our EC2 instance prompt. Okay. We have a few more commands to run. And they are here. We're going to run these commands and we ain't going to worry about any errors we may get. That looks like it ran successfully. Next command here. All right, and last. Copy. Warning, using a password on a command line interface can be insecure. Yeah, we understand. Don't worry about it, right? All right, now we're done here on our database server. We're gonna exit and it's gonna send us back to our application server. 10.1.299, we are there. This is where we're going to install Mattermost. And this is an example of a two-tiered architecture. We've separated the database and the application onto two separate servers. So it's not in one single point of failure in that regard. Okay, so now there's going to be several commands that we need to run to download, install, and configure our Mattermost application. And I'm going to paste them here into the notepad. Okay, these are our commands. First thing I'll do is sudo yum update, which I don't believe we did on this server. No packages marked for update, so it's fully up to date. Now let's go ahead and get our application for installation. All right, run our install command. Copy. All right. I always do that. All right. All right. The next command we need to run is to install some components onto our SQL server. And we need to put in the private IP of our SQL server. And that's going to be private IP of SQL server here. We're just going to paste it right here. Boom. I'll take this command, copy. Boom. Let that do its thing. All right, and now we have 4 more commands we need to run to get this all wrapped up. And they are here. Let's go ahead and run these. 1. All right. We're setting permissions, changing permissions. All right. We're going to move to our Mattermost directory. And final command here. Do. Okay, and this is probably going to take a couple of minutes to load and get the web page, get everything started and working. So we'll just wait a couple of minutes here, and then our Mattermost server should be successfully deployed, and then we will check that by visiting our page and taking a look. All right, now we're going to check and see if we can see our application running. So we're going to go back into EC2. We're going to uncheck database server. We're going to check our COM server, and we want our public IP address of the application server here. And we're going to open up a new browser, and we're going to paste in that public IP followed by a colon, and we're going to type in port 8065. You don't have to type the word port in, just 8065. Of course, you know that. And hit enter. And as you can see, we're on the landing page of our Mattermost chat app server, right? Look, Mattermost, all team communication in one place, searchable and accessible anywhere. Let's create your account. And you can go ahead and start creating accounts and creating groups on this chat application, hosted by you on your servers. All the data is controlled by you. And on top of that, it's an open source application, so you're not really paying anything for it, the application itself. You're just paying for your underlying hardware or your underlying environment, should you choose to deploy this in the cloud. And ladies and gentlemen, there you have it. Project complete. All right, so let's just go ahead and play around here. Let's create an account. Must be 10 characters, made up at least a whole bunch of stuff. All right, don't worry about saving that. Mattermost, all team communication in one place, searchable and accessible. Teams you can join. Okay, well, we don't have no teams. So let's just go ahead and create a new team. Name must be 2 or more characters up to a maximum of 15. Okay, too many characters. The rules. The team URL is gonna be this. And we're gonna finish that. And now we are in the main console. Welcome to Mattermost, your team communication all in one place, instantly searchable and available anywhere. Keep your teams connected to help them achieve what matters most. See what they did there? We could go ahead and skip the tutorial, town square, and there we have it. I'm in the cloud optimized team as myself, as Warner, and it's all built out from here. All right, my fellow cloud enthusiasts, this was a project to help you get your feet wet, and that is actually a viable and usable solution. Feel free to ask questions or leave remarks in the comments. And if this video was helpful to you, do me a favor and like and share the content. And until we meet again, happy clouding.